昨天是不是还开过一次？
对，昨天讲的是集团的显示，集团简介，然后今天就讲咱们在机检。
那个也是你们讲吗？
陈经理讲。
昨天也是讲。
哎，开始了，是的，开始。那把 OBS 打开吧，时间。
然后你把 OBS 打开，我这边。
那个也是讲吗？
这调用的不是这个，它调用的应该是那个。
它调用的自己的啊。
那把 OBS 打开吧。然后你把 OBS 打开。
延迟。
点对，开始。
管理还是
管理。
现在不正常了，对吧？应该进的就是这个媒体源，包括这些东西都 OK 的。显示器采集，一会儿让经理把这个一关，其实就采集到显示器上。我现在把那个 PPT 给投上，
你把那个网页上的关了。
网页上的关了，对，现在把这个关了。
对，昨天就直接。
As a manufacturing enterprise, Beijing Jingdiao is not an exception. Over the past 30 years since its establishment, it has always insisted that product development should return to the original position of a machine tool, a tool used for machining parts, and that it should focus on the original needs of customers, to be able to deliver, on time, with quality and quantity. By providing customers with high-precision CNC machine tools and comprehensive CNC engineering services, it promotes the better development of both customers and the whole industry. Jingdiao precision CNC machine tools can stably achieve 0.1 micron feeding, 1 micron cutting, nanoscale surface roughness, to meet the needs of micron-level precision parts processing. Jingdiao CNC engineering services are based on Jingdiao unique in-machine automation working mode, and provide mature CNC engineering solutions according to the needs of customers inside the industry. In order to achieve the above goals, over the past 3 decades, Beijing Jingdiao has established a product R&D system that is close to the needs of customers, independently completing the R&D of key core components and core technologies of machine tools, and realizing the integration of electromechanical software. A large-scale production system with lean manufacturing capabilities has been established, with a precision CNC machine tool production base of over 500,000 square meters. The machine tool host and key functional components are produced by self-developed equipment, with manufacturing and assembly accuracy controlled at the micron level. We have helped customers make good use of the application technology service system of Jingdiao machines, established a technical service team of over 1,200 people, and provided professional, timely, and efficient technical services to customers at home and abroad. The human resources system of digital technology application is supported, and accumulated over 20,000 talents who master digital technology to the industry through independent education, school enterprise cooperation, and hosting industry competitions. Nowadays, Jingdiao high-speed machining centers have achieved large-scale application in the Chinese machining industry, helping manufacturing enterprises truly achieve micrometer-level parts large-scale and efficient processing. Mountains and seas are not really barriers for sincere cooperation. In the future, we hope to work together with our European manufacturing partners to contribute our share to the development of the industry. Let's connect the world with precision machining. Join hands to create a brand new future. Connecting the world with precision machining. In every aspect of our daily lives, products of all kinds continue to improve the quality of life. And these products are made up of parts, and parts cannot be created without the manufacturing industry. Many companies in the manufacturing industry have been working tirelessly to ensure the accurate, efficient, and stable production of parts to meet the needs of upstream customers. maintain supply chain stability and ensure product performance and quality. As a manufacturing enterprise, Beijing Jingdiao is not an exception. Over the past 30 years since its establishment, it has always insisted that product development should return to the original position of a machine tool, a tool used for machining parts, and that it should focus on the original needs of customers, to be able to deliver, on time, with quality and quantity. By providing customers with high-precision CNC machine tools and comprehensive CNC engineering services, it promotes the better development of both customers and the whole industry. Jingdiao precision CNC machine tools can stably achieve 0.1 micron feeding, 1 micron cutting, nanoscale surface roughness, to meet the needs of micron-level precision parts processing. Jingdiao CNC engineering services are based on Jingdiao unique in-machine automation working mode, and provide mature CNC engineering solutions according to the needs of customers inside the industry. In order to achieve the above goals, over the past 3 decades, Beijing Jingdiao has established a product R&D system that is close to the needs of customers, independently completing the R&D of key core components and core technologies of machine tools, and realizing the integration of electromechanical software. A large-scale production system with lean manufacturing capabilities has been established, with a precision CNC machine tool production base of over 500,000 square meters. The machine tool host and key functional components are produced by self-developed equipment, with manufacturing and assembly accuracy controlled at the micron level. We have helped customers make good use of the application technology service system of Jingdiao machines, established a technical service team of over 1,200 people, and provided professional, timely, and efficient technical services to customers at home and abroad. The human resources system of digital technology application is supported, and accumulated over 20,000 talents who master digital technology to the industry through independent education, school enterprise cooperation, and hosting industry competitions. Nowadays, Jingdiao high-speed machining centers have achieved large-scale application in the Chinese machining industry, helping manufacturing enterprises truly achieve micrometer-level parts large-scale and efficient processing. Mountains and seas are not really barriers for sincere cooperation. In the future, we hope to work together with our European manufacturing partners to contribute our share to the development of the industry. Let's connect the world with precision machining. Join hands to create a brand new future. Connecting the world with precision machining. In every aspect of our daily lives, products of all kinds continue to improve the quality of life. And these products are made up of parts, and parts cannot be created without the manufacturing industry. Many companies in the manufacturing industry have been working tirelessly to ensure the accurate, efficient, and stable production of parts to meet the needs of upstream customers, maintain supply chain stability and ensure product performance and quality. As a manufacturing enterprise, Beijing Jingdiao is not an exception. Over the past 30 years since its establishment, it has always insisted that product development should return to the original position of a machine tool, a tool used for machining parts, and that it should focus on the original needs of customers, to be able to deliver, on time, with quality and quantity. By providing customers with high-precision CNC machine tools and comprehensive CNC engineering services, it promotes the better development of both customers and the whole industry. Jingdiao precision CNC machine tools can stably achieve 0.1 micron feeding, 1 micron cutting, nanoscale surface roughness, to meet the needs of micron-level precision parts processing. Jingdiao CNC engineering services are based on Jingdiao unique in-machine automation working mode and provide mature CNC engineering solutions according to the needs of customers inside the industry. In order to achieve the above goals, over the past 3 decades, Beijing Jingdiao has established a product R&D system that is close to the needs of customers, independently completing the R&D of key core components and core technologies of machine tools, and realizing the integration of electromechanical software. A large-scale production system with lean manufacturing capabilities has been established, with a precision CNC machine tool production base of over 500,000 square meters. The machine tool host and key functional components are produced by self-developed equipment, with manufacturing and assembly accuracy controlled at the micron level. We have helped customers make good use of the application technology service system of Jingdiao machines, established a technical service team of over 1,200 people, and provided professional, timely, and efficient technical services to customers at home and abroad. The human resources system of digital technology application is supported, and accumulated over 20,000 talents who master digital technology to the industry through independent education, school enterprise cooperation, and hosting industry competitions. Nowadays, Jingdiao high-speed machining centers have achieved large-scale application in the Chinese machining industry, helping manufacturing enterprises.
Good morning, everyone. Welcome to our online seminar today. I'm Yujing Chen from Jingdiao Group. I'm really honored and glad to be here to share with you a unique technology that can help us improve the machining accuracy and achieve a more intelligent machining mode. The technology is Jingdiao IMIM, which is short for in-machine measurement and intelligent modification technology. Before I introduce this technology, I want to show you a short video. So in this video, we can see there are 2 parts, and they are all finished in 5-axis machine tools, and a concave one and a convex one. The fitting accuracy between these 2 parts is less than 5 micron, and these parts can fit in not only one direction but 4 directions. And when we put them in, on the surface of a non-magnetic metal cube, the cube can be lifted up. And this is to prove that the fitting accuracy is so small between these 2 parts that it creates a vacuum space between them. So in order to machine such high precision parts, especially as we saw, these micron parts are standardized machined. To some extent, we need a high precision CNC machine tool, of course, and then we also need to make sure that the workpiece and the cutting tools are all accurate, as well as the whole process. However, there are many factors that may lead to the accuracy out of tolerance, such as workpiece deviation, inaccurate raw part allowance, and tool size deviation and tool wear. Among all these factors, workpiece origin deviation and tool size deviation are so common yet have so obvious influence towards the machining results. And to eliminate the deviation, we usually use the following methods. For example, we use dial indicator to align the part, or some machine may provide MDI functions to set the origin, usually for some simple shapes such as rectangular and circle, etc. And we may use trial cut to set the tool. Also, some machines provide MDI functions to set the length or radius of the cutting tools, but not the profile of the cutting tool. So is there a possible solution that we can obtain the data of workpiece and tools fast, accurately, intelligently, automatically, and compensate the deviation intelligently in not only 3-axis machine tools, but also 5-axis? Well, the answer is yes, and this is what IMIM is capable of. It can obtain accurate data of workpiece and tools and make compensation intelligently. This slide shows how it works. First, an intelligent NC program is programmed in our CAM software, Jingdiao SurfMail. Then it will be read by our control system. The control system will collect data by these sensors, after which the data will be fed back to the control system, and the calculation or modification will be made intelligently if it's needed. The parts we saw in the video at the beginning of our online seminar uses IMIM to set the origin automatically and measure the surface allowance and compensate the ball end cutting tool profile intelligently. And besides this part, Jingdiao IMIM is so widely used in machining all kinds of parts. Today, I will use several examples to explain what we can do with IMIM in precision machining. So first, let's see what IMIM can do in build precise coordinate parts in 3-axis machining and 5-axis machining, especially for complex and irregular shaped parts. When processing parts, the first work is to define the workpiece coordinate system based on the blank part. And sometimes the blank part have regular shape benchmark, such as what we can see on this picture. They are rectangulars and circles. But sometimes the blank parts are irregular and have polygons, ellipses, and special shaped borders, such as this part. In this situation, it's not easy to align parts based on these irregular features, especially with manual operation. Let's take this part as an example. So this is a CAM part. The border surface in green is to be machined. The original method the customer used was align the fixture manually and then use these 2 cylinders to fix the part and make sure the part is accurately fixed. So in this method, there are 2 errors. The manual alignment will introduce error to the clamping accuracy, and the tolerance between holes and cylinders is another error. So using this method to align the part can only get a 60% yield rate, which is not the best. That's the reason why the customer asked Jingdiao to help them to solve this problem. So Jingdiao's solution is using IMIM. We directly probe the top surface of this part. As we can see on this picture, these are all probing points on the top surface. And we also probe the 2 holes of the part and build coordinate system in Jingdiao CNC system according to the part's exactly position. So Jingdiao's solution is to adjust the data in control system instead of adjust the parts. So there needs no manual operation on the machine side, because the marrying program is finished in Jingdiao CAM software and the marrying, the calculation, the compensation are done by Jingdiao CNC system. And by using Jingdiao method, the contour machining accuracy of this feature can be controlled within 10 micron, and the yield rate increased to 99%. And in this picture, we can also say that after this part is finished, we can use Jingdiao IMIM to measure the allowance of the finished part. And this is the measuring results. And all these results can be timely shown on our screen of the control system. What I just introduced is a 3-axis example with irregular features of the parts. And next, let's see a 5-axis example. This is an automotive engine cylinder mold part. And because the irregular shape of this part, when the workpiece is clamped on a 5-axis machine tool, the MDI method or manual alignment cannot accurately compensate the spatial angle deviation of the workpiece. And this is how we can set the coordinate system of this part with IMIM. We use Jingdiao CAM software SurfMill to program the in-machine measurement and intelligent compensation program of workpiece position so that we can compensate the deviation in Z-axis, and also we can compensate the angle deviation in A-axis and also in B-axis. And this picture shows that we can compensate the deviation in C-axis and program the probing program in our CAM software as well. And all these measurement program are finished in our CAM software. This is the interface in Jingdiao CAM software of selecting features to build coordinate system, and then we can output the measurement path to the control system. So with Jingdiao IMIM, the Jingdiao high-speed machining centers will perform in-machine measurement program and automatically calculate the deviation in X, Y, Z, A, B, C direction in JD50 CNC system. And the JD50 system will run the G54.4 code and to compensate the deviation so that the coordinate system will be built according to the actual clamping situation of the parts in 5-axis machine tool. Thus, in the following processes, the machining is accurate. Let's watch a video about the measurement processing and also the following machining processing. And when we are machining die casting parts or 3D printed parts with 5-axis machine tools, it will be even harder to set the coordinate, as there is hardly regular features to manual align, and the accuracy of blank parts are worse than those blank parts that are processed before. However, with Jingdiao IMIM, we can also set precise coordinate system for the die casting parts and the 3D printed parts. And these are 2 videos. So in this video, we can see that if we don't use Jingdiao IM, we use manual alignment method to set the coordinate of this part. We will need around, the cycle time will be up to like 20 hours, because the die casting part has no regular benchmark, so that we need to first manual marking the parts, and then use manual method to align the part in order to find the right position of the part. But with Jingdiao IM, all we need to do is to finish the measurement program in our CAM software, and then the machine will measure the part by itself, and the cycle time will be reduced dramatically. With Jingdiao IM, we don't need any manual method or manual operation to align the part, and the cycle time will be reduced to 2 hours. And the 3D printed parts are widely used these days. And the problem that we are machining the 3D printed parts is quite similar to die casting part. And this is also an example that uses Jingdiao 5-axis machine tool to align the part and also to machine the part. This is a part that used in racing car. With IMIM, the alignment time is less than 3 minutes. After part is finished, we can also do the finished part in machine measurement to make sure that the accuracy of this part is qualified. So as we can see in these videos, the probe is quite like a cutting tool that we just put it in our tool magazine, and when the measurement is needed, and then we just change to the probe and use the probe to get the data of the parts. So at the end of this coordinate building part introduced, let's watch a video. It's an experiment to demonstrate that with IMIM, we can align workpiece without any manual operation, even there is very obvious deviation for the workpiece. Let's watch the video first. So in this video, we can see that at the beginning of this video, we insert a coin when clamping the part to create a very obvious offset. Then we put this part in the machine and the probe will start collecting data. The data will be fed back to the control system and the control system will do the calculation. Then the machine tool change a metal stick to insert into the holes randomly. And we can tell, although there is very obvious offset, the stick can insert into the holes accurately, which means that with IMIM, we can align the part, we can set the coordinate system very accurately. Yeah, and during the whole process, you won't feel that there is like a pause time that the control system is do the calculation or do the compensation. So it's very continuous process. And after the coordinate system is built, we need to make sure the cutting tools we use is also accurate as well. This is the second aspect IMIM is applied to. So we can use IMIM to do the cutting tools measurement and compensation. As we all know, actually the use of in-machine tool measurement system to detect tool errors has become the mainstream method in this industry. It's not new. The on-machine tool measurement system can basically realize the measurement and compensation of tool length and tool diameter, such as we use the contact tool setting to set the tool length, and we can also use laser tool setting instrument to set the diameter of tools, for example, the flat end cutting tool and also the ball end cutting tool. But the difference is whether we can use this instrument to measure the tool profile and compensate, and why we need to measure the tool profile and compensate. The reason is because in very high precision machining, the cutting tool's accuracy, especially the ball and cutting tool accuracy when we are machining surface, like this picture shows, right? The accuracy of the cutting tool, the actual accuracy, the actual size of the cutting tool is directly related to the surface allowance, the surface accuracy. And we also did some experiment. We measure cutting tools profile from different brands from different angle. For example, we measure the actual size of the cutters at 0 degree, at 5 degree, at 10 degree, etc. And we got this chart. Some of these cutters are Chinese brand, but some of them are really famous, worldwide famous cutting tool brand. But as we can see from this chart, the contour range of these cutters can reach more than 20 micrometers. However, this is quite normal because cutters are manufactured as well, so there must be some errors. But if we don't compensate these errors, there will be really negative influence towards the machining results. So the key to realize the measurement and the compensation of tool profile is still the combination between Jingdiao CAM software and Jingdiao control system. The output program generated in Jingdiao CAM software defines the process of tool measurement and tool compensation, and laser tool setter collect the radius data of the cutter at different angle, like 5 degree, 10 degree, 15 degree, etc. And then Jingdiao control system will calculate this data and make the corresponding compensation to each angle. Thus, the precision can be improved dramatically of the parts. This is also an example using IMIM to compensate the profile of ball and cutter. With the IMIM, the minimum cutting tool we can use is 0.75 millimeter. The radius is 0.75 millimeter. So it's quite small cutting tool. And the reason why we can use such small cutting tool to machine the part is also that we can make sure that the cutting tool is accurate and also the part is accurate. And the tool mark of this part at the cornering part is only 8 micrometer. Another very typical application of IMIM to mirror and compensate the cutting tools we use is that in precision grinding, we can also mirror the actual size of grinding wheel and also make compensation. Because why we do the measurement and compensation to grinding wheel is because that in precision grinding, the diameter of grinding wheel will also needs to be compensated. But the compensation to grinding wheel is different from compensating other cutters. Because as we can see in this picture, the grinding wheels are formed by bonding many hard, brittle, abrasive particles through binders. So during grinding, the abrasive particles may fall off or be damaged, so that the size of grinding wheel will change during the processing. And this kind of changes will affect the machining accuracy of parts. For example, the accuracy of the holes. And in this kind of situation, we can use IMIM as well. We can measure the size of grinding wheel directly and compensate. And we can also measure the accuracy of these holes and to calculate the data that needs to be compensated to the grinding wheel. And this video shows this process very clearly. Let's watch this video. So we can see in this video that before using Jingdiao IMIM, the customer's machining mode is like needs operator to set the grinding wheel and also to measure the hole accuracy after each process, right? So it needs a lot of time and needs the operator a lot of experience to have a lot of experience when using this kind of machine. So in this kind of mode, with this kind of machining mode, in 24 hours, only 3 pieces of this kind of part can be produced. But with IMIM, as I just mentioned before, we can measure the grinding wheel in machine to get the grinding wheel size, and also we can measure the hole accuracy as well in order to use the hole accuracy to calculate the data that's need to be compensated to the grinding wheel, so that on one hand, the efficiency will be improved dramatically, and also the accuracy can be ensured. With Jingdiao IMIM, And with this kind of machining mode, in 24 hours, 2 pieces can be produced. So before that, there will be just 3 pieces, and after that, we can have 2 more pieces one day. Now we can start machining, as we have make sure the coordinate is correct, and we are using the actual data of cutting tools to machine as well. During machining with IM, we can also do something. For example, to realize shape-followed machining. And this is also one typical application of IM. And as far as we know, I think this is the application that only Jingdiao can realize. So we will take egg engraving as an example to illustrate how it works. The reason why we take egg as example is because in batch production, so each part is like an egg. There are no 2 same eggs in this world, so as the blank part. There will always be difference between 2 parts, though they are from the same batch production. And there will always be difference between the theoretical model of the part and the actual condition of the part. So how to get the same machining result when there are difference from one blank to another, though they have the similar theoretical model and theoretical cutting path? We can use IM to adjust the cutting path, and this is how it's realized. As we can see on this slide, there is an egg, right? So what we have to do is, first, we build the egg model in our CAM software. So this is a theoretical model, the theoretical model of this egg, right? And then we set the probing points in CAM software, and also we set the probing path in the CAM software. And after the path is finished, we will output the path into the Jingdiao CNC system. And in Jingdiao CNC system, it will read the NC program and will run the NC program automatically. All we need to do is to press the start button to start the measurement process and also the machining process. And in Jingdiao CNC machine tools, the probe will follow the probing path we generated in the CAM software, and to probe the actual size or the actual shape of each egg. And then we use this data to compensate, to adjust the cutting path, the theoretical cutting path, into the actual cutting path in order to machine each egg. And then we can get a perfect egg engraving. So I will show you a video that to show the whole process. And this kind of shape-followed application can be used in real production. For example, in 3D product parts machining. For example, this one. So there seems to be a small problem about the internet. I will introduce these 2 slides again. So what I just said is that the shape-followed machining application can also be used in other industries. For example, when we are machining the 3C parts. For example, this part is actually the iPhone case, and we can use the IM to realize highlight chamfering because the iPhone case also has like some deformation from one part to another, right? So in order to get the same chamfering result, we use IMIM to do the cutting path compensation in batch production, so that we can have the similar results for each part. And the chamfering, the size of chamfering is even for each part. And one of our customers used to machine the wheel hub. There are also some chamfering feature on the wheel hub, and we can also use IMIM to do the shape-followed machining to get the even chamfering size of the part. So in the end of this application, I'd like to show you the whole process of egg engraving case. So let's watch this video together. These are eggs I just bought from the market. Today I want to engrave ASML on the surface of these eggs. First, I will write down ASML in the software and press this button to generate the NC program. Now the program is in the control system. I will randomly select an egg and clamp it in the machine tool. Now I will open the NC program in the control system. Press the start button. Now let's wait a few minutes. The egg will be finished. Now the egg is finished. Let's see how it looks. ASML has already been engraved on the surface of this egg. Okay, so in this video we see the whole process of how it works, right? So first, I just wrote some letters in our software, and the software will generate the program automatically, and then the machine will use the probe to get the actual data of the egg I just put into the machine, right? Because I collect the egg randomly. I didn't pick the one egg. I just pick a randomly egg because I want to show that. It's just not, not with a plot, right? I just randomly pick an egg and put it in the machine. And the machine will get the actual data of the surface and compensate in the control system, which you won't realize this process because it's very fast in the control system. The compensation process and also the calculation process will be very fast. And then we will change a cutting tool to engrave these letters on the surface of the egg. So we can also engrave a lot of eggs like this, right? With only one cutting pass, but it will realize the shape followed machining. That's why we call it shape followed, right? We can follow the shape and to realize the same result. Okay, so in machining, IMIM can also measure the parts accuracy and make judgments according to the program you finished in Jingdiao CAM software. And we will use this part to demonstrate. This is the housing part, and it is aluminum finished. The key dimensional tolerance is 5 micron, which is the distance from the right round surface to the left round surface, and the axiality is 15 micron for these two circles. the machining result is that the dimensional tolerance is 3 micron and the axiality is only 5 micron. So how we can do the in-process quality control or in-process dimensional accuracy measurement with IMIM? During process, if you want to make sure that some key features are qualified, we can use the in-process quality control with IMIM. For example, the tolerance distance, the distance tolerance from left circle to the right circle is 5 micron, right? As we just mentioned. So after the machining, we can do the mirroring and calculating automatically. And if the tolerance is smaller than 5 micron, then the machine will go to the next process, right? As we saw in this picture, right? If it's qualified, if it's less than 5 micron, then go to the next process. But if it's not qualified, like this, if it's not qualified, the tool length compensation will be made intelligently according to the calculating result, and the feature will be processed until the tolerance is 5 micron. So when the part is finished, instead of using 3-coordinate measurement machine to do the finished quality control, we can mirror the part in machine for both simple shapes and complex dimensional and positional accuracy, such as the verticality, the axiality, and also the cylindricity of this part. And this is the video that's how we do the finished part measurement. And all these machining and mirroring processes are driven by intelligent NC program that generates in CAM software SurfMill. And this program are what really matters. And also the G code do the calculation, the modification in the control system, because this makes it possible that the operator only needs to load and unload the part, as all the machining, mirroring, calculating work is done by the machine. And besides mirroring the dimensional and positional accuracy of the parts, IMIM can be used to mirror the allowance of the surface as well. And the mirroring result will be shown on the screen of the control system timely, just like this picture. So from different color of the points, we can tell if the surface allowance is qualified or not very directly. And this is an apply that only Jingdiao IMIM is capable of. So this is the whole process, how we machine this part. First, we use a Jingdiao 3-axis machine tool to do the roughing process. And then we just clamp this part in our 5-axis machine tool to do the semi-finishing, the finishing, the corner cleaning processes. Because there are really small features on this part, so we need to use the 5-axis machine tool to reduce the length-radius ratio of the cutter in order to get better surface and also accuracy quality. And now the part is finished. We use the IMIM to measure the allowance of the surface, right? And as we saw on the slide, the data will be shown on the control system in different colors. So this is also a very special application for IMIM, and as far as we know as well, this kind of application can only be achieved by Jingdiao IMIM. So with all these applications of IMIM I just introduced, the final goal we want to help our customers to realize is automatic machining. And this is how it works. So with IMIM, we can use it to set the origin, right? As we saw in the first part of the file, and then we can compensate the tool error intelligently as well without any manual operation, and we can do the incoming quality control and in-process quality control, right? Cutting in-process quality control, and also the finished part quality control, so that no human-machine interaction will be needed in the whole process, besides part loading and unloading, right? And this is what we call in-machine automation machining mode. And furthermore, we can also provide automation solution based on
让
this
模具
mode.
零件加工从靠人跑到数据跑。
We can also provide automation solution based on this mode because as long as the machine can run continuously, the part loading mechanism can make sense. So Jingdiao's part loading mechanism is called JDFMS, and there are automation line and automation unit that can provide to our customer. So with in-machine automated machining mode supported by IMIM and JDFMS, dark factory is not a problem. This is a video from one of our customers' workshop. The machine can run 24 hours, and even in night, the machine can still machining parts, so that our customers can sleep well at night and also enjoy life while the machines are running and making profits. Now, more and more customers from different industries are introducing IMIM and JDFMS to their factories. For example, we can see on this slide the customers from electronics and from automotive industry and also from medical industry. And this technology can also be applied to different parts with different materials. We can see we can use this kind of technology and machining mode to machine copper, right, and also to machine ceramic, graphite, or titanium, and also some brittle hard materials such as glass. And these are some worldwide famous customers that are using our solution, like Bosch, Samsung, right, and Best, Foxconn, etc. Okay, so from today's introduction, it's a really comprehensive, I think, and a thorough introduction of IMIM, what IMIM is capable of. From the very first beginning, IMIM can help our customers to build very accurate coordinate system. And then we can do the tool measurement and compensation with IMIM, especially the tool profile, and also we can measure the grinding wheel and make compensation as well. And in real processing, we can use IMIM to realize shape-followed machining, and this is very useful and helpful in batch production. And then we can do the parts accuracy measurement, not only for some simple shape, but for some really complex dimensional accuracy or positional accuracy. And also we can measure the allowance of the surface as well. And in the end, we can realize automatic machining with IMIM, because manual operation in the whole process are replaced by the machine by itself, right? So the machine can run continuously without any manual interference. And then we use JDFMS from Jingdiao to realize the automatic loading and unloading work, so that the machine will run continuously 24 hours. And this is what Jingdiao IMIM can support you to realize intelligent and continuous and also high accurate machining. Okay, so actually now we are also looking forward to more cooperation with customers from all over the world. And if you are interested in our technology or in our machine or in our automatic solution, you are warmly welcomed to visit our website or to contact with us. Thank you. So this is today's sharing. You can contact us through all these ways, or you can contact us through our machine dealers or our branch in Europe. And hope you enjoyed this sharing, and hope you to see you in the future or in the next time. Thank you. That's today's sharing. Thank you. Bye.